Hello, welcome. This is Birdy. Welcome to a new lesson in Houdini. Today we will continue our journey in the Pyro series in Houdini. Today we explain the smoke sourcing in Houdini in the sub level. So let's get started. So let's start, guys. So to understand the pyro, it has three steps. The first step is the pyro sourcing or the smoke sourcing. Depend what we are doing. If we are making a smoke or fire, okay. Let's make it first. We have the first step. That's name it the. For example, we have the sphere here, and it contains the density. It's what we need to make a smoke simulation. So this step, the first step is the smoke sourcing. Okay, the smoke source. I think it's like this. So the first step is the smoke source. After we make the sourcing of our and of course this will be in the sub level, okay. The second step is the smoke simulation or the pyro simulation, but we are talking now about the smoke simulation. So we import this sourcing inside the DOP network, so it's inside a DOP level, okay, and we import the density in the smoke simulation, okay. So in this step we import the smoke source or the density to the density field inside the simulation, and it make what we call it advect, okay. Advect, okay. Like every field react with the other fields, like density. If we have density and we have temperature and velocity, all these react to each other in the smoke simulation, okay, in a process called advect, okay, smoke advect. So the third part, let's name the third part like this. It will be in the sub level as well, again sub level, and we import what we make inside the DOP level, inside the smoke simulation, the DOP network, okay, to the sub level again, and we of course we will import the density as well, density like this, okay, to the let's say smoke import. So we import the simulation in the sub level to be render. So what we will render is this one. This is a thing that will be only render, this step, okay. This will be render. So this is the three step to make a smoke simulation. So let's start to make it in Houdini to see how it work, okay. Let's make a sphere. Everyone love sphere. To start with a sphere, let's name this smoke source. Get inside. We have two way to make the sourcing. The first sourcing by making just a scatter on the surface or scatter in the whole volume, then give it the density field, then import it in the smoke simulation. So let's make it. Let's make, for example, scatter. Now we have the scatter. Okay, let's give it more. And now we have this. Okay, then we will convert this scatter to. We should first create attribute. Let's say attribute wrangler, or create attribute like this, and we will call it density, and it has a default value is 1, size 1, and default value is 1. So every point will have a density as a float. Then we will convert this volume attribute, volume rasterize attribute. So of course we should make like this: density, yeah. As we can see now, we have the density, but of course it become much bigger than the original sphere that we have. Why? Because we have here something called the B scale. When we make the attribute create, of course we don't have here a P scale, but in this node convert the point to a volume, as we can see here, volume rasterize attribute. So it convert the attribute from a point to a field as a volume. So now it's become a volume VDB volume. Okay, and its type is a VDB volume, not volume. This is a VDB, not volume, not ISO offset. Yeah, that's what I mean. Okay, so we have something here called particle scale. We can minimize it like this. Okay, and minimize the filter is the minimize size. It so it cannot be less than this. Minimize something like this. Okay, so what's happening here? What is the B scale? Let me explain what is the B scale. When we have a sphere, right? And then the sphere we convert it to a point in the surface, right? So after we convert the point, this is a geometry, geo, and this is a point or a scatter, and this is the volume. This is the volume. This is the volume, the VDB volume. Okay, so every point it make something like a circle around it, or its range. Okay, so every point has a range. So every point has a range. Okay, a range like this. Okay, so this range, the point in the center, and it has a range or a circle surrounded. This is a B scale. So when we decrease the B scale, it will give us a small density or a small sphere, and when we increase it, it will give us a big scale. So that's why it can be small or it can be big. It depends on the B scale itself. Okay, so this is the B scale, and this is what happening when we increase or decrease the B scale. As we can see here, it's a shallow. It doesn't have an interior. It doesn't fill the interior. It only create because of course the point in the surface only. We don't have point inside the sphere. So to have a fill to fill the volume, we must first scatter this points inside and out, inside the sphere and on the surface. As we can see here, the point only scatter on the surface. So we should make it ISO offset or VDB. It doesn't matter, both will work, but I will make it as a ISO offset, much easier. Okay, so we have we convert the sphere first to a fog volume. Let's make it 100 maybe to give us less more voxel, and then converted all this point or scatter all this point in the volume itself. So as we can see now, we have a point inside the sphere and on the surface. So if we give it the density attribute, then convert it, now as we can see, we have volume in both inside the sphere and on the surface, not only on the surface. Okay, I hope it makes sense. So this was the first way to make a density volume or sorting the smoke. Okay, let me just change the background to a dark. As we can see here, we have the domain and we have the pixel. We can also make, I think, if you want to see it, we can make a VDB visualization tree. Visualize tree, I think it will work. Yeah. Like it's solid box, but I think it should be has small voxel size. Yeah. Also, if I clip it, let me make -1 0 like this. As we can see here, it fill all the sphere, but if we just cancel this ISO offset, as we can see now, it's become a shallow because we scatter the point on the surface only, as we can see here, right? Okay, so this was the first way. Let's make the second way. The second way, let me just first change this from mesh to polygon, but it won't change anything in the scatter itself. Yeah, it's the same scatter. It doesn't it doesn't affect the scatter if it's a primitive or mesh. Okay, so we have the sphere now. Let's do the same thing, but in only one node. It's called Pyro Source. So as we can see here, the Pyro Source, it simply scatter point on the sphere. Here in the mode, by default it choose keep input. What's keep input? Keep input simply is the same points. We keep the same points that we have in the geometry, but we delete everything else. Yani we will only keep the point, but we will delete the everything else. As we can see here, we have a point primitive vertices mesh, and here let us see what we have here. We have only point. We don't have a primitive or vertices. We have only a point, right? So this the point. As we can see here, this is the point, same as the point here, right? Also, if you want, I can add node and choose delete geometry. So I deleted the geometry. As we can see here, this is only the point, and when we choose the Pyro solver, we will keep the point we have. Okay, so this is the keep input. It's keep the point that we have. It doesn't create other point. But I think we have here particle separation. Let's particle separation wouldn't work. As we can see here, if we increase or decrease this particle separation, it wouldn't work because we choose the keep input or by default. Okay, let's delete this. So that's the second input. The second mode is surface scatter. So it works same as the scatter, right? So it will create our scatter points on the surface only, and now we can decrease or increase it by the particle separation. The particle separation is the distance between every particle, how much it should be. So of course, when we reduce this number, we will have more and more points, because the distance will be, we will reduce the distance, we will decrease it, right? So we will have more and more points. Okay, and we have also here particle scale. Okay, so a particle scale, now I understand the surface scatter. It's same as the scatter, but of course it doesn't have this option like relaxing or don't relaxing. It doesn't have this option. It just relax the point on the surface. It's same as scatter, same as we make a scatter node, but with less option. Okay, only the option of the point and option the relaxation is checked. Okay, so the third mode is the volume scatter. As we can see here now, it's make it scatter the point inside the sphere as well, not only the surface but inside the sphere as well, like ISO offset. Same as if we make an ISO offset to fill it with density, then we scatter the points. Same as thing. This is the same, but except here it has a noise or randomization in the position, but here we don't have a randomization. Every point has the same space with the other points with the particle separation. Let me type 0.5. We will have more and more particle. Okay, so now I think we understand the three mode, right? Then we have a particle scale and the particle scale and the attribute. Of course, here we make and create attribute called density. So here we don't have to add a create attribute node. If we simply just choose a source smoke, it will create for us two attribute, one called density and the other called attribute. If we check here, now we have two attribute, one called density and the other called attribute and temperature, and both are float, same as here, same as here, same as we create a density, it's attribute density it's a float attribute, right? But instead of make an attribute create node, it created for us. So we have source fuel. It can create an attribute called fuel and attribute called temperature. Fuel for the explosion and the fire. We need the fuel, but in the smoke we don't need the fuel. We only need density, and we can have the temperature or we don't have the temperature. يعني it will work. We don't have it, we don't need even the temperature. We can convert inside the dome simulation or the smoke simulation the density fields to a temperature field, as we will see later. Okay, so we can make it like this, custom. Let me choose density, and that's it. Or you can choose it from the source. And of course we have source color. It create for us. Let me see again. Create for us color attribute and alpha attribute. It's for the color. Okay, so let's go back to the smoke. Let's choose density for now. So we have default value is 1 and scale is 1. What's the default value and what's the scale value? It's the value for the density value. If we type here density, density, it's in the point, of course. This point attribute inside the point itself. If I just write this, and as we can see here, we have the position, the density, and a group particle. Okay, so let us focus only on the density. So let's type density. We will see the density now. This is the default number times 1, and the scale, it multiplied in this number. So for example, if we type it here 0.5, so 1 multiplied by 0.5, it will give us 1.5, right? So all the point has a value of density 0.5. If we type it 0.1, it will give us 0.1, because 1 multiplied by 0.1, it will give us 0.1, right? And same thing if we do this here, it will give us the same value, but this is the default value and this is the scale. In general, it multiplies this number by this number, and it gives us the value of the density we have. So this is the first step. Now we need to rasterize the density from an attribute point to a volume field. So how can we do this? Same process, same thing. We will use the volume rasterize attribute. So let's choose volume rasterize attribute like this, and we should type here the name of the attribute that we want to rasterize it from an attribute to a volume. As we can see here, there is a big difference from this scale and this scale, but not very big. We can control it by the size of the B scale, as we can see here. And also this is a minimum filter, so now we can make it very, very small or very big or things like this. Okay, as we can see here. Now if we make the particle scale like this, but we want to increase the we want to increase two things. The voxel size, we have only 23 voxel in each axis, so the number the total number is 6,000 and 163, and the size of the domain is 2.3 in the x-axis. The whole size of the boundary box or the domain 2.3, 2.3, 2.3. So maybe we need, if we see here, okay, maybe we need to increase the but it's hard to see the voxel, the field inside the voxel. I don't know how to show it, to be honest, but we can increase the value like this for the density. As we can see, as much as we increase this number, as much as we increase the value of the density here. So we have a very intense smoke or density, right? As we can see here, spreadsheet, every particle will have 8.65 density value, and of course here it will have the same number as the field itself. Okay, just make it 1. I don't need to make it much, maybe make it 2, it's okay. Okay, so this is how we convert it to a volume. And now we can add a null and just type it, the out smoke source, something like this. So we can use this as the smoke source. And that was it for this lesson. If you have any question, please type it in the comment section below the video. Also, don't forget to like the channel and share it with your friends. And if you like to support us, you will find us on Patreon and Gumroad. And see you in the next lesson, and have a good day.